Good morning. This is Unit 1, Day 3 notes. We're just going to take another look at piecewise functions. Piecewise functions are functions defined by different formulas for different intervals of the independent variables, which is x. Standard notation is given in this format. So we say y or f of x equals, and then we use this curly bracket, and then we can break it up into 2 or 3 or even more different formulas depending on the domain. So let's look at an absolute value. The absolute value function, absolute value of x, kind of looks like a v, and we can see that it's actually split up into x as long as x is greater than 0, right? So that looks like this. If we just say x, my slope is 1 over 1, I'm going up 1 over 1, and we're doing this part of the absolute value function. Now if we want to go down for the other part, the other half of the absolute value function, to go down, we're actually going to say this is negative x. And this is if x is less than 0. So this is negative x. It still has a y-intercept of 0, but we are going to go from left to right. We are going down 1 over 1, down 1 over 1. So these two functions make up the absolute value of x. Is the function above continuous? State the domain and range. And where is the function increasing and decreasing? Well, it is continuous. So this graph goes on infinitely to the right, and it goes all the way down, but the purple one starts where the blue one left off. There's no gap here, and it's going to go infinitely to the left. So is the above function continuous? Yes. State the domain and range. The domain is going to be from negative infinity to positive infinity. The range is going to be, it doesn't go down here, it's never going to be negative. So it starts at 0. And actually we can include 0. And it's going to go only up. They only go up, 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 up. So it's going to go all the way to infinity. Where is the function increasing? So it's increasing on the blue line is increasing. So increasing is going to be 0 to infinity. Remember, increasing, decreasing, that's always asking you for the x values. It's decreasing on the purple line. So it's actually going, the x values go from negative infinity over to the left, negative infinity, all the way to 0. Now this might be something new for you. This is called the ceiling function and the floor function. So I always think of these as kind of like a step. When the little bracket is on top of the x, we're gonna always push everything up. So when the little bracket looks like this, is called the ceiling function, where x is the least integer greater than or equal to x. So if we're between 1 and 2, we're always going to move it up to 2. Okay? We're going to sketch the graph from the interval of -3 to 3. So right here at -3, when we substitute in -3 into x, it's just going to give us -3. But anything over -3 is actually going to shift it up to -2. So it's going to look something like this, something like we have an open circle, and then all the way to 2 to -2, and then this is a closed circle. And then we're going to start at -2, open circle, and then we're going to go, this one's open, we're going to go all the way to closed circle. And then at -1, it can be -1, but anything over -1 is going to be 0. And then we're going to keep on going up, open circle. We're going to go close circle. Open circle. Now they can't overlap. So open circles are on the ends, and then closed circles are on the right-hand side. Okay, it's going to look a little bit different for the floor function. So this one is going to be pretty much the complete opposite, where x is the greatest integer less than or equal to x. So if we substitute in, let's go down here to -3, and we substitute in -3, we can actually include this one. We're gonna leave it down. So even at like -3.2, it's still gonna be at -3. We're gonna round down always, all the way until we get to 2. But when we get to -2, we can include that right here, -2. But this whole step is going to be included at -2, and then this is going to be an open circle, because when we actually substitute in -1, we can go up here to -1, open or close circle, and then we're going to go all the way over, open circle. We're going to just keep on doing that. Close circle, make a step, open circle. Okay? I'll just finish it since there's only one more. This one's open. Alrighty. Evaluate this piecewise function. Okay, so this gives us our domain when x is less than 1, when x is between 1 and 3, including 1, not including 3. When x is greater than or equal to 3, we use this one. So let's look at, we're going to substitute in 12. 12 is greater than 3. So that means that I have to use this one. So this one is 5 minus 1/2 when x is 12. 1/2 of 12 is 6, so 5 minus 6 equals -1. Now when f is 2, or x is 2, we can't plug it into this one because this is only when x is less than 1. So it has to be plugged into this one. And really we don't have to do anything, it's just 2. I want you guys to try this one. Tell me what happens on this one. When we plug in 0, 0 is less than 1, so we have to plug it into this one. So I'm just going to -2, absolute value, 0 plus 1, absolute value. The 0 plus 1 is 1. The absolute value of 1 is 1. So -2 times 1 equals -2. And that's okay, because the -2 is on the outside. That's fine. So let's try this one. We're asked to evaluate this when we have 6. So which one do I plug it into? The top one or the bottom one? This is when x is greater than 2, and this is when x is less than or equal to 2. So I have to plug it into the top one because 6 is greater than 2. So then we're going to plug it, or substitute it in. 3 times 6 minus 7. 3 times 6, 18, minus 7 equals 11. I want you guys to try B. This one, it's asking you to name the graph. So what is the equation of these lines or parabola and then tell me the domain restriction. So I'm going to help you do one. Let's try this one because it looks more difficult. I'm always going to start with the left-hand one, and this is when this goes on forever to the left, right? There's an arrow here, and it stops right here at 2, but it is closed here at 2. So this is when as x is less than or equal to 2, we have to use the parabola. And the equation for a parabola is, it looks like the slope is just like up 1 over 1, so it'll be x squared, and then minus the y-intercept. So it'll probably be negative 3. So x squared minus 3. Now in between 2 and 5, so 2 to 5. But they're both open circles, so x has to be less than 5 and x has to be greater than 2. We have to use this line. And this is a horizontal line, which, remember Huxley, horizontal line is undefined, and then V-O-Y. Vertical line. So this is a horizontal line, and this looks like y equals negative 2, and that would be the whole line. And this restricts it from positive 2 on the x values to 5. So this is going to be, the equation is negative 2, since our y values are down here, and it's a horizontal line. Now this one, it looks like we can include 5 and go on infinitely. We have an arrow right here on the end again, and it goes on forever to the right. So this one is when x is greater than or equal to 5. And these should pretty much pick up where the last one left off. So this is just a straight line. We can actually find the y-intercept if we keep going, and I think the slope is up 1 over 1, so it'll just be x. And I think if I keep going, the y-intercept is negative 3. Check it out and make sure. And this one only works if x is greater than 5. So my first step, what I want to do is just split up the domain. We're going to use this one only as x is less than or equal to negative 1. So over here on this part, we're going to have the blue graph. And then the red graph only works between this negative 1 and 4, but we can't include both. So they're going to have open circles on both. And then the green graph only works as long as x is greater than 4. If it's hard for you to graph these, you might want to make a table. This is just a parabola. Since it's negative 1/2, it's going to be facing down. It's already in vertex form for me, so I'm just going to try to graph it like that. Remember, whatever is inside the parentheses, we usually do the opposite of. So instead of x plus 4, it's going to be to the left 4. And then whatever's on the outside of the parentheses, we just keep that sign. So plus 3, that's fine, go up 3. And this is going to be a point of this parabola. And it's going down, and my slope is going to look something like this. Check it, make sure. Something like this. Might not be perfect. But we do have our calculators. This one goes down forever. And this one does not. This one cannot include the asymptote is going to be like around here. It does not include this. Now, we're going to go to the red graph. The red graph, remember this is a V, an absolute value sign. We're going to go to the opposite way instead of to the left 2. We're going to go to the right 2. And then we're going to go down 4 for our V. And then the slope, it makes it go up 3 and then over 1, up 3 over 1. It's symmetric. 1, 2, 3 over 1. And this one we cannot include either. So we're going to have an open circle. And this is going to be an open circle. I'm sorry, I thought this one was this when we can include one. So this is going to be a closed circle. Alrighty. Now we're going to go to the green graph. The green graph is a cubic. So a cubic kind of looks like, I don't know, an S, sideways S or something. So we're going to move it to the right 6 and then up 2. And it might look like this. And then usually it's symmetric about the origin. So something like this. And we can get a couple more points to kind of try and make sure. I know that if I do substitute in 4, I can try this one and actually see what happens. It looks like 4 minus 6 is negative 2 cubed, which is negative 8 plus 2 is negative 6. So something like this. And this one we can include, so this. And then this one goes up infinitely. And that's what this piecewise function looks like. I really encourage you to go ahead and pause the video and read this because I'm going to go through it pretty quickly, and I had to pause it and read it and make sure I understood it myself. They want us to write a piecewise function. So I'm going to say, and it says in t of x, so t of x is given by, and remember we saw the standard form kind of looks like this, and it looks like we're going to have 1, 2, 3. So when x is less than 125. It looks like if your taxable income is at least 0, but not more than 30. So our x has to be at least 0. You have to make something, but not more than 30,000. Then this is your rate, and it's going to be, we usually convert this into a decimal, so we bring it over twice, and it's going to be 0.15x. That's how you're going to tax yourself. Okay, however, if it's in between 30 and not less than, but not more than 65,000. Ooh, I put an extra little equal sign. Then your tax is going to be 4,500 plus 0.2, move this over twice, times x, however much you make. Now we have one more, we'll have this one. If our x is less than or greater than 65,000, you make more than 65,000. However, it's still less than or equal to 125,000. Then we can use this one, which is 11,500 plus, remember we move this over twice, so 0.24 times x. And this is our piecewise function. Now it says evaluate the function to find the tax owed by a single person whose taxable income is 68,750. So we need to know which one to plug it into. Is 68,000 between 0 and 30? Nope, not this one. Is 68,000 between 30 and 65? Nope, can't plug it into this one then. 65 and 125, perfect. We actually have to use this one. So what we're going to do is t of 68,750. We're just substituting in for x 68,750, and I know I have to use this one. Equals 11,500 plus 0.24 times, and this is a real life situation. This is how taxes work, 750. This is a calculator thing. I don't even know this. So something like, well, I want you guys to try it and let me know what the answer is, okay? And I want you guys to try the other one. If you have any questions, please ask me, let me know. Have a wonderful day.